Okay, so here we've got a table that has gasoline mileage and 10 different automobiles. So it gives the weight in pounds for the automobiles, and it's in thousands of pounds. So for example, this 2.5 is really 2,500 pounds, and this is 3,000 and 4,000, etc. And then here's the gas mileage underneath for Y. All right, and let's notice as we look at this, appears to have a negative linear correlation. It's negative because it is a negative slope. It's going down from left to right. We want to answer the three questions. We want to calculate R. Based on R and the scatter plot, we want to tell, is linear regression justified in this case? And then we're going to predict the gas mileage for a car that weighs 4,200 pounds. All right, now, first, let's calculate R. Now, you won't ever have to calculate R by hand except to do what we're about to do. Notice here from the StatCrunch regression plot that R squared is listed here. Now, it's listed as a percentage, and we want to change it into a decimal. So 92% as a decimal is 0.92. Now, that's R squared. So let's take it to another page. R squared was 92%. And it's not supposed to be capitalized. It just tends to do that in Word. So think of it as little r squared. All right, so to get R itself, all we need to do is take the square root of this so that we just have plain old little r. So the square root, and I'll use my little draw feature here to draw my square root symbol. And let's put that into the calculator. I get approximately 0.959. Now that's quite close to 1, and it's certainly bigger than our little rule of thumb, 0.75. So that's a strong, positive linear correlation. So when we go back to the slide here, it asked, based on R and the scatter plot, is linear regression justified? Yes, we have a strong R value, and of course in the picture we can see that that line is quite close to the data that we've got there. So question 3, predict the gas mileage for a car weighing 4,200 pounds. Now let's notice for all of the X values, they used the 4.2, so we want to use the 4.2 as well, not the 4,200 pounds. All right, so here is our regression equation right up here underneath the regression plot title. So let's write that thing down and we'll take it over to our computation. So it's 70.1058 minus 10.6175x. And we're going to plug 4.2 into x. So I'm plugging the 4.2 into x and then putting this into my calculator and letting my calculator do the work. And when I put that into the calculator, I get 25.5. We'll just round it to 1 decimal place since I think that's what all the rest of them are rounded to. Now, let's check our graph and make sure that that sort of coincides, just to make sure that we haven't made a silly mistake. So we put 4.2 in, we got 25.5. If we go back to our picture, 4.2 would be right in here somewhere. 25.5, that looks reasonable. That looks very close to right around 25.5. It matches our regression plot there.